So welcome to another device management working group meeting. Remember, we are bound by the Kubernetes Code of Conduct, which basically means be kind to each other. The topic today, the one that I added to the agenda, and we can see whether anyone else has other topics, is about the ongoing KEP discussions for Kubernetes 1.31. I'm sharing the PR. It's again a pretty big one and lots of discussions, but we are getting closer, I hope, to some kind of conclusion of what to do and what to not include. My intent is to just give you a summary of what we've been thinking with this PR, perhaps explain why certain things are removed, on what we have added instead, and then raise some particular aspects for discussion, which is about whether we should still support classic DRA in 1.31 and what we do with resource quota or device quota handling for devices in general, because that is one of the opens, I think, that we still have with different ideas floating around. Does that sound okay? Any other topics?
I think that sounds great. It'll be easy for folks to review if we can get a summary of what's been agreed so far.
Yeah. Okay. Then I'll just keep talking about this PR's description and not necessarily go to the specific aspects of a PR, although I might do, for example, for the quota later on. So, as you know, as was presented in previous meetings, we started a prototyping session to figure out what the real API for DRA should be going forward. John was driving that, and we then homed in on something that ended up being called DRA evolution in that repo. That was the consensus between Tim Hawkin, John, myself, and Kevin. I feel a bit bad that we couldn't involve more people, but this really was a very intensive discussion with multiple meetings per week. It just wouldn't have been possible to get to that point with just the device management meetings, for example. The strong ask from Tim was that we remove everything that is not absolutely required. Get rid of historic baggage or past decisions, or revisit past decisions to make sure that the thing that we now put into Kubernetes for the long term really is sustainable and has a nice usable API. That's the API aspect. We decided, Kevin, sure. Feel free to just go on.
Yeah. I just wanted to throw in there that the idea, just to echo what Patrick said and expand on a little bit, is that the idea is that the API we get in for 131 will be in a state that we can have it go to beta in 132. We need something in beta, as soon as possible. And this is what we've honed in on to hopefully make it to beta just one release later.
Yeah, that clearly is the motivation. So things that we dropped because we just couldn't really, or were not convinced about the specific use cases. First is custom resource definition as the main user-facing API. We dropped that partly because the new API is expressive enough to have the selection parameters in the in-tree format based on device attributes, and then it also has raw extension fields for vendor configuration parameters. So those are still possible. They just get embedded directly in the in-tree types. And we think that this covers most of the use cases. The immediate allocation mode is something that we had originally envisioned or inherited from the storage API. And there was some thought that it might be useful for certain things. But it became a bit obsolete already with structured parameters, because structured parameters by definition only do allocation when a scheduler support. So we basically dropped it didn't have a meaning with structured parameters. It was only there for classic DRA, and now we are completely removing it. I know that Abhishek has had some questions around that. I think you can get a similar effect with what is now always what was called the wait for first consumer mode. Your driver, if you use classic DRA, can simply ignore what the scheduler is asking and just do the allocation either immediately when it sees a claim or ignoring whatever information it gets from the scheduler, and then you get a similar effect.
I mean, it doesn't even need to wait for the scheduler. It can have
Right,
an informer on the claims themselves and then just allocate things.
Yeah, and then it might even do that quickly enough so that the scheduler doesn't even need to create a pod scheduling context object and immediately sees that the claim is already allocated and then just uses it. Then there is some historic baggage that we got rid of. I was in 130, I was still very, well, I try to be very formal about what I called device model, but that hasn't survived. It wasn't necessary. We have now the idea that devices is what we deal with. They have attributes, and then we have certain query languages or constraints that use those attributes. And if we change one thing or the other, it'll still, it should still work. You could describe your devices using a different format in the future, as long as they still have attributes, and the query mechanism would still work. So it's not a tight one-to-one between how to publish the device information and how to select devices anymore. Overall, I'm quite happy with the API. I think it makes a lot more sense now. We reconsidered what it means to have a class. At the end, we pushed that down one level. So instead of having a resource claim, which always needs to reference a resource class, we now have a claim which asks for multiple devices, and each device request references or can reference a device class to inherit some settings that have been prepared by an admin or by the device vendor. It's currently optional. It's not such a strict and required thing as it was in the past, but this is still under discussion because it might be necessary to make it required for quota purposes. And that at the moment would be the only reason why a device class would be required.
Patrick,
yeah.
Can you elaborate a bit more on this topic? I didn't.
Yeah.
You said
Yeah.
there is a resource claim.
I can add some flavor there too, I think.
Yeah, can go ahead.
So, traditionally the resource class was there so that you could, put some initial constraints on what type of devices could be allocated, what driver it came from, things like this. And then your claim had to reference that. It said that this claim is tied to allocating devices from this specific driver with these constraints in place. And we've now relaxed that for the next release, where a claim doesn't just have a single type of device it can allocate. It can allocate multiple devices that are selected in different ways. And so because of that, instead of having a top level resource claim, we now have a device claim so that each of those requests can reference a different class that has, constraints and potentially a driver name associated with it. And the piece that Patrick was saying about it's not necessarily required anymore is because you don't have to have a class to put these constraints on or name your driver if you want. You can actually do that directly in the request for the type of device that you want. It doesn't need a class to kind of build up what the initial set of things need to be put in place for the driver to be selected. You can do that manually yourself. It's really just there nowadays to, it's kind of syntactic sugar is the wrong name for it, but it's a way to kind of bundle up a set of common constraints that you would want to use to request a device, and so that you don't have to copy and paste those into every request that you ever make. Again, with the caveat that we may need classes at some point for something like quota, but at least in the way that it's currently defined, it's completely optional.
But the request. Oh, sorry. There was a
Yeah, go ahead. I can add something else. So
Yeah,
there is one other purpose, but I can explain that later.
I was the mechanism is the same. It's the resource claim, right? The only thing is that before it was a one-to-one relation because of the device class or class whatever to a driver, and now we relax this one-to-one relation to mean can be one-to-n, something like that.
Yes,
But
that's exactly right.
Yeah, because a claim can now request multiple devices. It can request a
Perfect.
GPU
Yeah.
and it can request a NIC, and those both
Yeah.
get bound to the same claim, and each of them can have a separate class.
Abhishek, I think you're next.
Yeah, so yeah, I mean, I'm coming up to speed with this. The question here is, I mean, in previous one-to-one mapping, it was obvious that you have to specify a class name. So in this mode, who does the validation, whether the user is specifying a correct class name for the desired claim?
There is, in that sense, no correct device class. The user basically needs to know a little bit about what he wants and how to ask for it. It could be that the vendor says, to get my device, always use this particular class, and then it would be the job of the admin to make sure that this class actually exists in the cluster. Instead, the vendor could also say, to get one of my devices, ask for a device with the following driver name and the following device attributes. And then the user puts that directly into their claim request without specifying the class. It's up to the vendor to basically to define or to explain how to request certain devices.
Okay, so this would be exposed via some documentation, right, by the vendor?
Yeah, the vendor basically
by
needs
the
to.
vendor.
Yeah.
I think
Yes,
that's the key
yeah.
point. It's up to the vendor how they want to do this. I think for GPUs, we would still ship a device class with our driver that would be called gpu.nvidia.com, and it would force you to pull from that specific driver when you select devices in your claim request.
Mm-hmm.
So the device class basically has the same fields or the same selectors as a claim request. It just comes pre-configured. There is one other thing that I wanted to add about device class. It also has configuration parameters that get applied to devices that use such a device class. And because those configuration parameters are set in a privileged object, the device class, the driver theoretically could distinguish between settings that can be chosen by a normal user in their claim versus settings that can only be chosen by an admin in the device class. So that is the other, besides the syntactic sugar, that's the other purpose that the device classes currently have. We don't have a very strong use case for this, but this was part of the original design also that this should be supported. So depends on the driver that they actually have such privileged configuration options.
Okay.
Then let me continue with the other thing. So this all so far falls under simplifying the API, but we also wanted to make it more capable than what it was in 130. One of those things that we've added is the match, so-called match attributes. We want one claim that asks for multiple devices to be able to define what we call constraints. Constraints are the things that apply to a set of devices and limit which devices can be combined in a claim. The only mechanism that we have for that right now are these attributes identified by their name must have the same value in all devices. And depending on the attributes that devices have, you could say, well, they all need to be on the same PCI rule. That was our go-to example so far. There's one caveat. We are not standardizing any attribute names at this point. So it would be up to the vendor to say, I'm publishing my devices with the following attributes, and you can do matching like this with these attributes, but the support is there. And we are attribute names. I think I should say a little bit more about those. So attributes have a name. They are scoped to a certain domain, and we are reserving the KAS.io namespace for future standardization. All other attributes by default are vendor specific. So the vendor basically publishes information, and they control their attributes and what the attributes mean. But they can also specify some of these future standardized attributes at the same time, and there's no ambiguity. We are not putting that into this cap, but it could be a document that anyone can publish as long as they own or define the namespace and own the DNS domain for that. So it doesn't even need to be Kubernetes who standardizes some of these things. If there's a vendor consortium that believes that they can define some common attributes for a certain device class, that certainly would be possible also without doing anything in Kubernetes. Okay, and there's no question. Then the next one is so-called admin access or management access. We haven't quite nailed down the name. It's, for example, useful for monitoring purposes where you want to deploy a daemon set that runs on all nodes with certain hardware available and gets access to that hardware independently of other pods using that same device. So one implication of admin access, and the main one as far as scheduling is concerned, that it doesn't block the device for other pods or other claims. It basically gets access and just silently sits on a node and does some simple observations, hopefully non-intrusive. So that's the admin access. It is a privileged operation. We don't want normal users to be able to access any device in the system just by asking for admin access, because then they might use or might get access to the same hardware as some other user in another namespace. So that's where we need quota policies or quota mechanism. There is one defined in the cap that says in this namespace admin access is allowed, and if it's not allowed, it's denied by default. Then this use case that I just described with a daemon set that wants access to all devices, that only works if we also put in another feature, and that is a definition of a request that has a device selector. So it can say, okay, I want to monitor GPUs, and I want to monitor all GPUs that are available or that exist on a node. And this all is a special flag that you can set in a request using this new API. Okay, Abhishek?
Yeah, so I had a question, like how is that daemon set requirement different from admin access?
It's well, it's orthogonal in the sense that you could write a normal pod and with a normal claim without management or admin access that says, I want all GPUs. You can do that. And then the daemon set for monitoring would also say, I want all and I want admin access together. Both are separate attributes of a request.
Yeah.
The difference is that if a normal claim asks for all GPUs, they actually have to be available. If any one of those is in use at the moment, the claim will not get satisfied.
Yeah, but so the use case there, just to clarify, at least in the case of GPUs, is that you will land on a node that has all of the GPUs available. It guarantees you that you land on a node that has all GPUs without having to specify a specific number.
Mm-hmm. Okay.
That's the point with the daemon set or with the all, that it supports nodes where the number of devices is different, and you don't have to know that in advance.
Mm-hmm. Okay. Thank you.
While adding that, we also added a fixed amount of devices. That would have been, if you know how many GPUs you want, you could have a claim where you replicate the same request n times. That works. You can do that. But it's kind of cumbersome if you know that all of those GPUs can be identical. And now we can say, give me 5 of these kind of devices. It has a little bit of implications for making those devices available in a container. Traditionally, and that is what we had in 130, you could say this container here gets access to the devices in this claim, and it would get access to all devices. We have extended that to saying, okay, give me all devices in this claim, or you can also say, give me access to this request in this claim. And this request then is by name, so the requests need to have a name for this purpose and some other things. And then you can do, say, a pod with 5 containers, a corresponding claim with 5 requests, and each container gets 1 GPU from one of those requests. And this is one case where you have to replicate requests. At some point, we discussed whether we should have an index number so that you could get 5 identical GPUs and then say, first container gets the first one, second container gets the second, but we dropped that. You need to use different requests if you want to have that granular access for the containers. Yeah, I think that's the last bullet point. I didn't actually read it. So selecting devices from a request, that is the one that I just described. Then the rest of the changes in the CAP are some editing. Okay, another question.
Yeah, so the match attributes don't select the devices.
No, the match attributes are, we are distinguishing now, the language is claims or set of devices have constraints. That's what determines whether 2 devices work together or can be allocated together. And then we have selectors for devices. And the selectors, they, as the name say, they select devices from the candidates that are available in the cluster. And that is always for a single device, essentially, or a set of identical devices.
Okay.
Okay. So some editorial changes. So this is one of the decisions that we made at some point. We are keeping the resource KSIO API group. We keep resource claim, resource claim template, but the focus is a bit more on devices. So I also removed resource driver in favor of DRA driver in a few places. That's just updating the language a bit. So that the next section in this PR description is basically for John, Tim, and Kevin. It explains what I added to the PR after our initial discussion for DRA evolution. So the resource slice, resource pool discussion for background, we in the DRA evolution, we said we'll rename it to resource pool. But then when I thought about this all devices use case, I realized that we need a bit of stronger semantics so that the scheduler can actually tell whether it knows about all devices on a node. So we need to have a stronger concept of what is a pool. It's also relevant for identifying devices in different places. We now have driver name / pool name / device name as a unique identifier. You can put that into a string and it's guaranteed to be unique in the context of DRA. And this pool concept is pretty much the new thing that we added, that I defined in this CAP for the first time. And so far, Kevin and John have reviewed it. I think we think it makes sense. We still need Tim's approval or comments, but we kept the slice name because conceptually this pool this individual resource slice object, it's not the complete pool. It might have to, the pool might have to be split up across resource slices because there is a size limit on some of these fields that we have in the object to make sure that it fits into the 1 megabyte limit that we have in Kubernetes. So the consumer has to assemble basically a complete list of resource slices, say for a node, and then it knows what the entire pool is. Then the amount that I described earlier is a new thing, per request constraints. That was another idea that Kevin brought up during the KEP PR review. I mentioned constraints. This is basically a statement saying the following of the devices must have the same match attribute, but we could also say if you have 3 requests, 2 are for GPUs, 1 is for something else, you could say the match attributes only apply to the first 2, which are my GPUs. Those must have a match attribute with a certain value. And then you could also match against all requests, all devices with another constraint that covers perhaps different device classes or different kinds of devices. And that again uses the mandatory request name to identify what the constraint applies to. So last but not least, I updated what I now call classic DRA, the original KEP in this PR. Tim at some point suggested that we should just remove it. And I think the writing is on the wall. This is probably something that will happen eventually. I just don't think that it's now a good time to do it. We are still in the process of identifying all the things that people have done with classic DRA and making sure that the same things can be done with structured parameters. So it would be, in my opinion, a bit too early to drop the classic DRA, but it's now reduced quite a bit in scope. The API is different. The CRD removal affects it, for example, but you can still kind of do the same things because you do have the config parameters where you can place things if you need additional parameters. So it's kind of still works, but we really need to think hard about what to do with it going forward. And that is, I think, the task for the working group for the time after 131, that we look hard at all the things that people still need classic DRA for, and whether that is something that, can be moved to structured parameters.
There was a question in the chat, Patrick, about migration
Okay, I don't see that.
from. That's fine. I can repeat the question and attempt to answer it. So the question was about migrating from the existing device plugin API to something like DRA. So at least in the case of GPUs, we plan on maybe not right away, but by the time everything goes beta, or at least definitely by the time things go GA, to provide a mutating webhook along with our driver that will take people's existing pod specs that have the extended resource way of requesting GPUs and turning that into, creating a claim on the fly and then mutating the pod into a way that asks for GPUs the DRA way. And the main reason you have to do that is that the device plugin and the DRA driver cannot coexist on the same node. They can't, by definition, govern the same set of resources. And so you need to be able to run one thing that has that view and allocates them. I think Avishek and some of the people at IBM have already built something similar to this for a system that they've been developing that's been working with a DRA prototype. And I don't know if we'll just adopt what they have or ship something different, but it'll look very much like that. Does that answer your question, or did you have something else in mind when you asked that? It was Neha, you were the one that asked the question.
Yes, so my question was related to, and I'm sorry, I'm running behind as well. If we have thought through and discussed about, we already have a device plugin way. If we move from device plugin model to this new DRA, is there any migration flow been discussed and thought through?
Beyond what I just explained, or you mean from like the driver developer's perspective?
From driver developer perspective.
Let me think how to, I mean, it's a different way of advertising and thinking
Right.
about how you build out your drivers. But with the simplifications that we've made for, in classic DRA, there was a lot of stuff that the driver implementer had to do, right? That was very different than the existing device plugin API. You had to write a kubelet plugin, which did a whole bunch of stuff. You also had to write a control plane controller that knew how to do allocations and how to communicate and interact with the scheduler and
Right.
build some communication protocol between the kubelet plugin and that control plane component. And so it was fairly complicated to put something like this together. With structured parameters and the way we're moving forward, this control plane piece doesn't need to exist anymore. And we're going to provide libraries that make it easy to advertise the resources that you have available, so that the scheduler or whatever other components can pick those up. And so, with the new way of thinking and having a lot of the support built in tree, the responsibilities of the driver implementer have gone down quite a bit. There's still more work that needs to be done than what you have to do for, a device plugin, to support the device plugin API. But I have the feeling that it's not going to be too much more, and you're going to feel like you have a lot more power in how you can actually, advertise the resources that you have and make them available. One thing to consider is that if your API that you want to present looks almost identical to what you do for device plugins, except that you want these resources to be made available to claims, then I don't actually see you having too much work that you have to do. Instead of just publishing an opaque string that represents your device, like you do in the device plugin API, now you will advertise that same opaque string, but you just advertise it the DRA way.
Got
And
it.
instead of implementing an allocate call that comes in from the kubelet, you'll now implement two calls: your node prepare resources call and your node unprepared resources call. And if you don't actually have a whole lot to do in those two calls, there's not a whole lot that would need to be different than what you do in the existing device
In the
plugin.
existing one. And we are not going to decom the device plugin, right? That's a GA. I
Yeah.
think Alexander pointed a good part in the chat that if my scenario continue to work with the device plugin, I don't need that level of granularity in the DRA. I can continue to use that.
Yeah, the device plugin is not going away. We've always positioned this as an alternative way to request resources.
Got it.
And if you want to do it the simple way, you can. The one caveat being that if you only advertise resources using the device plugin, you obviously can't reference those in resource claims because it's a different API for advertising.
But can I use them? I think, sorry, Geeta has a question. I have had a similar. Geeta, you want to talk about that?
Oh, yeah, so I'm trying to understand how the cluster moves from device plugin to DRA without disrupting the workload. Is it one node at a time, or do they just remove the device plugin, daemon set, and install new one, and there is disruption?
Yeah, so if you want, so you can't have them both running on the same node at the same time. That's, I think, I said that at the beginning. I think that's clear. So if you did want to move from one to the other, you would have to, drain the node and bring it back up with, the DRA driver rather than the device plugin. But that doesn't mean the workloads necessarily have to change. And so this is what I was saying at the beginning is you could, along with your driver, you can also provide a mutating webhook that knows how to take the existing, extended resource way of requesting resources and transform that into a DRA way of requesting resources. So that behind the scenes, you end up creating resource claims and asking for devices the DRA way, but your workloads are still asking for them using extended resources. So they could still land on any nodes. Some of your nodes could be running the old plugin, some of them could be running DRA, and depending on where the scheduler, decided to schedule them, then it would use one or the other. But I think that, at least in our internal clusters for GPUs, the way we plan on supporting this, like with the GPU operator, for example, is that at least to start, we won't have one of these mutating webhooks, and the recommendation will be that, you know, you dedicate some nodes to running DRA or advertising resources the DRA way, you dedicate some nodes to advertising extended resources, and then workloads that ask for GPUs the extended resources way are going to land on the nodes that have that.
Mhm.
The nodes, workloads that ask for resources the DRA way, they're going to land on those other nodes. And then slowly we'll introduce this mutating webhook once we gain confidence that the DRA way is, you know, more stable and usable, so that, you know, you can stop deploying the device plugin, but now you can ask for resources either of the two ways, and it will work with the DRA driver under the hood.
So Kevin, one follow-up. You mentioned you can, on the same node, I cannot have both. Even if it is managing two different separate devices, I may have a system component which is driven by a device
Sure.
plugin.
If they're different devices, then you can, but
Yes.
you need to make sure they're mutually exclusive. You can't advertise the same resources and
That makes sense.
with the device plugin and with DRA. And the reason for that is just because at the end of the day, in the device plugin model, it's not the plugin that does allocations, it's the kubelet. And so there's no way to actually coordinate the allocations across the two plugins, because they're not making the decisions themselves in the old API.
Okay, so there is no order guarantee. So that makes sense. Two separate devices completely.
Yeah.
Okay.
Thanks.
I wanted to add one more thing about writing a DRA driver for structured parameters. So what I have open is another KEP update that already got merged. It was based on discussions that we had with SIGAUF about how to actually publish resource information. So with a device plugin model, the kubelet plugins, they publish or they give information to the kubelet, and the kubelet publishes that information. We used the same approach in 130, but it does have one major drawback, and that is that kubelet, the control plane, and the drivers running on the node need to agree on the encoding of that content, of this payload that gets published by kubelet on behalf of the drivers. And what we are now doing instead is that the drivers themselves are responsible for creating resource slices. That's one of those things that is likely to change, or may, well, yeah, we don't envision specific changes, but it could change. And we want to get to a point where you can leave your kubelet at an older release version and then update your drivers, update your control plane, and it will still work. This kind of version skew between kubelet and the control plane is important, because updating kubelet is so tricky in some places or in some clusters. There are security implications for that. So we basically deploy your DRA driver as a daemon set with its own service account that gives it permission to write resource slices, or using RBAC rules. And unless you do some additional work, this would give your local driver on one node permission to access everything in the cluster and potentially interfere with other nodes, which would be bad for security. What we have identified with SIGAUF is the mechanism using validating admission policies, a feature that SIGAUF supports, to limit the scope for the certain daemon set instance to its own node again. So it's comparable to what we had before with kubelet from a security perspective. But it is something that DRA driver developers need to think about themselves. It's not enforced by Kubernetes. It can't be, because it really depends on how this thing gets deployed. So that's perhaps one thing to keep in mind when you engage with writing a DRA driver. We will have something in our DRA example driver that shows how to do that. But yeah, this is still to be done. Okay, we have 20 minutes left. I think we covered well, perhaps we haven't quite covered classic DRA. Do we have anyone who wants to chime in and say that it can be dropped or should not be dropped?
I mean, a small comment there is classic DRA did handled MIG use cases. So MIG slicing, especially for NVIDIA GPUs here specifically. I mean, that's not present here in this structured parameter versions. So,
That's
that
correct.
is,
Yeah.
So that is one feature that, we would eventually or soonish like to be part of the structured parameter DRA implementation. And then, I mean, at least I can vote from IBM side that classic DRA could be dropped.
Yeah. Once we
Yeah,
have it. Okay.
Me and John are still pushing to have that be part of this release. So we'll know more by Friday, let's say, if MIG is going to make it in or not.
Okay,
Or
thank you.
partitionable devices in general, which would support MIG.
Mhm.
Yeah, it would be interesting to hear more whether there are other reasons. I think one other thing is custom policies around allocation. If you really need something that is more elaborate than match attributes, that could be one potential use case for classic DRA. Yeah, it will be interesting to see. But I hope to get it included if we think that during the implementation phase that we really don't need it. I think we could still drop it, but I'm not sure yet. So it depends on your input, essentially, whether we keep it, drop it, or just postpone the decision and give us the criteria to decide when to drop it. Okay, but enough about that. The other open that we have is around, now I need to see whether I can find exactly the right section where I made that comment. So resource quota. It should be, I need to unfold that. GitHub is so annoying sometimes. I know that the text is there. It's just not showing me the text. So I need to unfold the div first. And then I can search for the part that I wanted to jump to. So yeah, we talked about, I mentioned quota. And that's not actually it yet. So we are going back and forth between should resource quota be enforced at admission time or by the schedulers while allocating things. The difference is partly user experience, but I don't think that aspect really matters that much. With admission at theory, the user would get immediate feedback if they try to ask for something that is too much, that exceeds their quota. That's how the traditional pod resources and so on work. The problem is that in practice, users don't create pods directly, and they also don't create resource claims directly. They create a resource claim template, and then some controller creates the claims for them. So this admission error wouldn't actually be surfaced immediately to the user either way. It would just show up as an error that a controller encounters and then needs to advertise as events or status information for the user. So this immediate feedback, I think that is not a real difference. We shouldn't use that to decide what to do. The other argument in favor of admission time checks is that the schedulers then become simpler. If they see a certain claim that has been admitted, they know that they can allocate it or that they should allocate it without additional quota checking. I have an issue open where I'm pointing out a few drawbacks where this just doesn't work well. One immediate impact would be that we need mandatory, the alternative with admission checks is that we need mandatory resource class or device classes classes. Because we ultimately, what we could do at admission time, it has to be fast. It can't rely on actual resource slices. It can't do complicated cell checks on all the devices in the cluster. That just would be too slow and probably not acceptable for something that has to run fairly quickly in the HTTP put handling of the API server. So what we could do is something like counting classes. And ultimately, the quota would be, in this namespace, you can use this device class n times, but not more. And then the device class has to be written in such a way that actually expresses something about the desired quota. If it's just... Sorry? Okay. No, I was trying to quickly find the corresponding issue. I think I need to open a tab for it, but let's get to that later. So this is one of the things that kind of work. You can limit the device by type, limiting amount of GPU memory consumed in a namespace. That already becomes harder. The device class basically needs to say, this device class is for a GPU with 10 gigabytes. And then you can limit it to, say, 100 megabytes in a namespace by saying not more than 10 of these. But then if you have two different devices, all with different amount of GPU memory, you can't really sum up. I just don't think it works. But I still need to convince John and Tim of that. So what you and the working group can do is you can basically share more information about the kind of resources, resource quotas, device quotas that you want to implement. And then we can check whether the current proposals do that. So this section here is about the current proposal that is in the CAP. It has the Boolean for allow admin access. And what I've added today is two mechanisms that I think are feasible in 131. The maximum device number is further down. It's a simple maximum counter for things that match certain selectors. So it's the same API essentially for requesting a device. It's just limiting the number of those devices that you can use in a namespace. And then for the quantity for the GPU memory use case, I'm defining this here, an attribute name, which could be GPU memory. The total of that amount, of that quantity, must not exceed a certain value. These are things that the scheduler can evaluate, and it needs to treat those as additional constraints for the set of devices that exist, not just for this one claim, but across the namespace. The downside is that this needs to be implemented in the scheduler. It would be in the in-tree scheduler, so the cluster autoscaler, which uses the same code, will automatically support this, but not other schedulers that use completely different logic, or other autoscalers like Carpenter. They also need to implement quota support to be accurate. Let me go back because I know that the issue description has the corresponding issue number. It's this link here in our prototype repo, where we basically have a few open issues with things that we were discussing, and quota mechanism is one of those. So I started the description with what I'm proposing. I also included the alternative that was mentioned in some discussions. But as you can see at the end, we don't really have a conclusion yet. Okay, any questions, comments on that? So the thing is, we need to decide about that roughly now, because it does have implications on what we are putting into the API, whether, for example, the device class is now required because we want to make quota based on it. These are the decisions that you need to make now. Even if we don't implement the quota mechanism immediately, we still need to know at least how we do it. Another implication is that if we add something like it later, how does it affect schedulers that don't know about the new fields that probably will be needed? This is a strong, a lot of discussions that we had are about this kind of API design, so that our API is future-proof, so that we can make future changes to it to add things without completely breaking old components that haven't been adapted yet to a future API revision.
Yes, I think one thing I'll throw in here now that you're saying that is, if there's one place to focus on reviewing this KEP, it's the code aspects that Patrick just went through, because these are the biggest open questions that we're still debating, and we'd like more feedback on what people think the right way to do this is, and if it's worth, requiring a class to do class-based quota, or if it, if that is, obviously not sufficient for the kind of stuff we want to be able to do. Does it make sense to do quota at allocation time rather than, admission time, like it's traditionally done with the existing quota mechanism? These are the things we need, people to put their input on so that we can, sway it one way or another.
And the best place to put those comments, in my opinion, is the open issue. So this one here, because then it's a bit more focused than the KEP discussion. It's always tempting if you see something in the KEP PR that is related to it to comment on it. But I think I already counted 3 or 4 places about device class being mandatory just in that one KEP PR, and it's all related, all coming back to this one issue here that we need to discuss. I think a bit more focused discussion in that issue would be useful. Okay. But
before we finished, I added another topic about failures and how to represent failures in pod status. Can we spend a few minutes to discuss it?
Yeah. I think I was just about to ask whether we have any other questions about this stuff here. If not, then yeah, let's move on to your topic. Yep. Let's go.
Yeah, sorry, I cannot turn on the video. I have some technical problems. So I started this KEP to expose device failures in a pod status. The idea is with the device plugin, we already returned the health status of a device, and this health status today only affects the allocatable amount on the node. And the hope is that pod will just crash by itself because device is unavailable and unhealthy, and customers will somehow discover it themselves. The connection between the failed pod and device unavailable. Proposal is to expose this information as a pod status, so it will be easier and it will be a universal way to check like what was wrong with the pod. And if you see that devices were unhealthy, then it gives you a lot of ideas what could have gone wrong. Yeah, I wrote this KEP and I wanted to apply it to DRA, but I have a trouble understanding how to get device identifier for the pod status. So in DRA, we already have device name. It's kind of unique on a node, and most of the time it will be unique on a node, so we can use it. And what customers can do with this device name is they can understand that is it the same device on a different pod was failing or not. As a minimum, they can know on a single pod if it's flaking back and forth from healthy to unhealthy. They can track that. As I said, on device plugin, you likely will also know like cross pod, like was it the same device failing or it's a different devices failing.
Yeah, so
but I
one
don't
thing
think on
is,
DRA you can do it. Go ahead.
oh, sorry. I was going to say that I think we just finally came to a conclusion on what a unique name like this would look like last night. And the canonical name for a device will now look something like driver name / pool name / device name. And that's guaranteed to be globally unique for any device in the system. So I think, because I read at least parts of your KEP. I think I commented on, this specific thing of what does a resource ID even mean in DRA, and I think we now have an answer for that. unless Patrick thinks something else would be used there.
No, I think that is exactly what this new device ID is useful for. So I agree. We also discussed a little bit how to get that information from the driver to the kubelet. I'm not sure whether you already saw it, but I think both
Yeah,
Kevin
we
and I
commented on it
today
in our
commented a
data.
little bit.
Yeah.
Yeah. So some more movement in your CAP PR.
Oh, okay, I haven't seen this comment yet. Thank you very much. So
Yeah.
the idea is that it will be possible to propose provide a health state from DRA plugin to kubelet, right?
Yeah, so the comment that we left today was about how to do that. And I kind of, in the comment, I gave a summary of how the device plugin today kind of reports health. It doesn't actually report health. It just adds and removes device IDs over time, and the kubelet infers health from that. What I was proposing for DRA is that we actually have a similar API call, which is like a list and watch. But instead of just sending opaque IDs to represent the devices that the kubelet knows about, we could send an ID along with some metadata that tells the health status of that device. And so you end up with a similar API for how you get the list of devices that you care about between DRA and the existing device plugin, but you would just get a richer set of information from DRA, and then you could perform similar operations then to actually populate your endpoints that you're exposing. If that makes sense. Go ahead and read the comment and comment on it if
Yeah.
if
Thank
it
you very
makes
much.
sense or not. Yeah.
Antonio?
Yeah, I think that's an interesting idea. It's also aligned with the concept that you implemented with CDI, right? Now we are going to have named device.
So CDI is the name of the device that the container runtime needs to know about, which is different than the name that we're pushing out through and standardizing on for what you can look up in the API server to represent the device. Yeah, they are different names.
They are different names. Okay.
Yeah, by definition they have to be. Yeah,
So
I
that
mean,
you were consolidating this. Okay.
yeah, I mean, in theory, you could make them look similar if your driver wanted to, but CDI is a very specific format.
Okay.
And
Then
so,
forget the
yeah,
comment. I was mapping
Yeah.
both concepts. They are not.
yeah, okay. David,
Thank you.
did you have something you were gonna say, or is it just your microphone? Oh, okay.
Okay, so we are at the end of the hour. I hope you found that useful. I certainly look forward to comments on the PR, comments on the open questions. If we have nothing else, then thanks for your attention and goodbye.
All right, thanks, Patrick.